In a standard normal distribution, the mean, standard deviation, and z-score are related. So if you have any two, you can find the third. For example, suppose the monthly number of new customers for a company has been normally distributed with mean 500 and some standard deviation, where the probability that the number is less than 400 is given. A new marketing strategy is expected to increase the monthly number to have mean 550 and a higher standard deviation. Let's find the probability that we fall within some interval. Since we're given a probability that's less than 0.5, we know that x equals 400 must be less than the mean. So we'll let it correspond to some negative z prime, and we note that by symmetry, the probability that z is greater than positive z prime must be the same, and so the probability that we're less than or equal to z prime is the complementary probability, and that allows us to find z prime. And so this 400 must correspond to a z value of negative 1.25, and that allows us to recover the standard deviation. Now that means y will be normally distributed with mean and standard deviation. We'll find the z-scores at the boundaries. So we're looking for the probability that we fall in an interval. So this will be the area to the left of 1.8, from which we'll subtract the area to the left of negative 1.8, which is the same as the region to the right of 1.8, which is complementary to the area to the left of 1.8. So our probability will be the area to the left of 1.8 minus the complementary probability. Or let's consider another problem. The amount of beverage filled into each bottle by a machine is independently and normally distributed with mean 12 ounces and standard deviation something. Approximately 20% of all 24-bottle cases contain more than 290 ounces of total beverage. Let's find our standard deviation. So let y be the amount filled into a single bottle, then the total amount x filled into 24 bottles. Remember, the means and variances add, so the average amount will be the sum of 24 copies of the average of y, and that will be, and our variance will be the sum of 24 copies of the variance. That's the square of the standard deviation, and so the standard deviation itself will be the square root. Now we're told the probability that we're greater than 290 is 0.2. So that means our complementary probability must be 0.8. And this corresponds to a z-score of 0.84. And since we know our amount, our z-score, our mean, we can find the standard deviation. So filling those in, we get or let's buy some light bulbs. Suppose our light bulbs have a mean of 3 and variance 1, and we want to find the smallest number of bulbs purchased so that our set will last for at least 40 months with probability at least 0.9772. So concrete doesn't hurt. Suppose we buy 9 light bulbs. The total lifetime of these bulbs, well, that'll be 9 times the lifetime of the individual bulbs, and the variance will be 9 times the variance of the individual bulbs. So our mean and standard deviation will be Now, for the probability the total life is greater than 40 months, that gives us a z-score of, which is actually off the table, and that means our probability is pretty close to 0. So we'll certainly need more than 9 light bulbs. So if we buy K bulbs, then the total lifespan is normally distributed with mean 3K and standard deviation square root of K. And we want the probability to be 0.9772 or more. Since this is greater than 0.5, it corresponds to a z-score to the left of the mean. And again, we'll call that minus z prime just to make the variable itself have a non-negative value. By symmetry, the probability that we're less than positive z prime is the same. And we find that x equals 40 corresponds to z equals -2. Now recovering our k value gives us and so k solves this equation. To solve this, we'll let n be the square root of k, and so our equation becomes, which, pick your favorite method of solving a quadratic equation, has solutions n equals 4 and -10/3. So that means k is the square of n, so k is 16 or 100/9. Now, remember, we want the probability that x greater than 40 to be greater than 0.5, which means that 40 has to be less than the mean. But if k is 100/9, the mean will be 100/3, 33, and so 40 will actually be greater than the mean, so k can't be 100/9. On the other hand, if k equals 16, the total life of the bulbs will be normally distributed with mean 48, standard deviation 4, and our z-score, -2 as promised, and so our probability that we exceed a total life of 40 months is going to be at least 0.9772 as desired.